Hello student, this is circle. You know that circle is a set of points equidistant from the central point which is called center. So you can see that here O is the center, BC is a chord, right? OA is the radius, which is the longest chord is always a diameter which passes through the center. And if I take here RS, this is called R, which is the minor arc. If I consider the larger side, the piece of a circle, that's called major arc. So what is the meaning of tangent? Tangent is nothing but a line which touches circle at only one point. So if you will see here, AB is a tangent which is touching circle at P only, right? If it is touching more than one point, then it becomes a secant. So any tangent, it can be a line segment. You can see that CD is a line segment. So I can measure the length of CD, right? It is touching circle at C. So how many tangents can be in one circle? Because circle is a collection of infinite points. So from each point, I can draw one tangent, right? That's why we say there can be infinite tangents on the circle, but only one tangent at one point on the circle. Than that, here what is the secant? Here if you see here, secant is passing through 2 points, it intersecting circle at 2 point A and B. So xy is called a secant, not a tangent. Now you will learn two theorems based on tangent here, that those are called tangent theorem. The first theorem says if you take tangent, that is always perpendicular to the radius at point of contact. So look at the figure here, there is a circle, xy is a tangent at P and OP is the radius. So we will take here XY is perpendicular to OP. How can we prove it here? Any point on this line, right? Now if you will see here all these points, because it is a tangent, so these are going to be, if I take here Q or R or S, all these length from the center, OQ will be greater than OP, OR is going to be greater than OP, similarly OS is going to be greater than OP. So you can see that the shortest distance is going to be the perpendicular distance, XY is going to be perpendicular to the radius OP. Right now, what is the application? Where do we use these theorem? We use this theorem to find out the length of the tangent. You can find out or length of the tangent or distance between center or and the exterior end of the tangent. So you can find out here. So this is one of the question from point P. The length of the tangent to a circle is 24. You can see that the length, which is PQ, is a tangent length, is given as 24 centimeter, and distance of Q from the center, this is point Q, from the center it is given 25. Now you can use the theorem that the tangent is always perpendicular to the radius at point of contact, which is P. Now this is a right triangle because tangent is perpendicular to the radius, so you can take OQ square equals to OP square plus PQ square, the radius as 7 centimeter using Pythagoras theorem. There is one question in your exercise also, parallel tangent. How many parallel tangents can be there on a circle, right? Because we have seen there can be infinite tangents, but how many parallel tangents are possible? You will get a pair of parallel tangents only at the end of the diameter. So if AB is a diameter, you can see. How can we prove that this is parallel? There was a proving question. So AB is a diameter. If I draw PQ tangent and RS tangent passing through the point of contact A and B, right? We have to prove that these two of them are parallel. Now you can use our first theorem, the tangent is always perpendicular to the radius. So for parallel, we can take it here. So if this is 90 using clear linear pair, this will be 90. So angle PAO, you can see that alternate interior angle, which is angle PAO, which will be equals to angle OBS. And since alternate interior angles are equal, you can say lines are parallel. Or what can we take here? Angle OAQ plus angle OBS is 180 degrees. So which property is this? Co-interior angles are supplementary. That is why you can say that PQ is parallel to RS. Then in this chapter, you will learn another one more theorem which says the length of the tangents drawn from an external point. So you can see that here, if I'll show you the figure here, these are the two tangents. This is a circle right? P is the exterior point, and if you'll see, PA and PB are the two tangents drawn from the exterior point. If we need to prove that both of them are equal, because here what is to prove? What does this theorem states? That PA is always equals to PB. Construction O to P, which will divide it into two triangles. Now, if you divide it into two triangles, from theorem 1, the tangent is perpendicular to the radius. So this angle and this angle is going to be 90 degree. The radii of the same circle are equal, and OP is the common side, which is opposite to 90 degree, which is hypotenuse. So using RH congruent, POB are going to be congruent, these two triangles. The moment you say congruent, you can take PA is equals to PB, PA will be equals to PB by CPCT. Which is MCQ question. It says PT and TQ are the two tangents drawn from the exterior point such that the angle POQ is 110. We need to find out the measure of angle PTQ. Property of a quadrilateral is 360 degree, right? Now you know that tangent is perpendicular to the radius, so this and this angle is always fixed, which is 90 and 90 degree. So what can we say that here? If you will add 90 and 90, 180, right? 180 plus 110 is going to be 290. So 360 minus 290 is going to be 70 degree. POQ by the two tangents plus angle inclined between two tangents, which is PTQ, is always 180 degree. Now, other than that, you will see what is the meaning of quadrilateral circumscribing a circle or a triangle circumscribing a circle. So, if a circle is inside the quadrilateral, where all the four sides are, which is are going to be the tangents, because the circle is going to touch each side here at one place. So how many tangents you can see in this figure? There will be four tangents. In the sum of opposite side is always equal, right? So what are the opposite sides? If I'll take it here, AB plus CD will be equals to AD plus BC. The same theorem, there is another result also. Here, if this quadrilateral ABCD is a parallelogram circumscribing a circle. So which kind of question you will see there? Now the same figure, instead of quadrilateral, if ABCD is a parallelogram circumscribing a circle, and if they have given you this length as 10 centimeter, now you know that any parallelogram circumscribing a circle will become a rhombus. Now rhombus, all the sides are equal, and if I have the one length of one side as 10 centimeter, then the perimeter of the parallelogram is going to be 40 meter. Now here this is another, this question also you have done as a proving part here. What does it say here? This is again a quadrilateral circumscribing a circle. So ABCD is a quadrilateral circumscribing a circle, which is, then there are four tangents AB, BC, CD and AD. Now what you need to remember here, angles subtended by the opposite side to the circle, right? What are the opposite sides here of a quadrilateral? AB and CD, right? And AB is subtending at the center angle AOB, and CD is subtending angle COD as at the center. So what are you going to do it here? Sum of these two angle is always 180 degree. Similarly, if it is opposite tangents, the angle subtended by these tangent at the center, and these two angles are going to be supplementary. After that, a triangle circumscribing a circle means where is a tangent to the circle, BC is another tangent to the circle, AC is another tangent to the circle. Now you know that O is the center, and radius is always perpendicular to the tangent. So if I take this as PQR, then OP is perpendicular on AB using the first theorem, OQ is perpendicular on BC, and OR is perpendicular on AC. There is a subjective question also based on this, right? Now the tangents drawn from exterior point are equal in length. So you will see these three of them are equal in length, right? These three pairs. So AP is going to be equals to AR. Then here BP will be equals to BQ, right? And CR is going to be equals to CQ. Now, if they are, you need to find out the radius, then you will use the area part, right? Now you know that what is going to be, what is another result here? Area of triangle ABC will always be equals to area of, now there are no triangles, right? So what I can draw it here, triangles, because I have to divide this whole big triangle into three small triangles. So how can I take it here? Look at here. If you will join OA, OB and OC, there are three triangles. And if I area plus this triangle area and then this triangle area, I'll be reaching to the whole area of that triangle. So I can take it here. What is the first triangle here? Triangle AOB plus area of triangle BOC plus area of triangle AOC. Why the area will be equal? Because the occupied space is same, and using this you can find out here radius or some unknown.
Thank you for watching this video. Please like, share and subscribe. Also, keep practicing.